So just like we took a look at that there is a mapping that allows us to go from the relational database up to some object representation, we can also do the same thing with XML, right? We saw that JDBC and JPA and all these libraries allows you to very easily map between these two worlds, right? Allow us to have a map a table and the fields and foreign keys and primary keys represented in an object oriented by using all these annotations, one to many to many, and whatnot. We have the same type of support in Java that allows us to map these two worlds. So let's take a look at the example, a real quick example here where we have students that contain several students. We have Alice and Bob, each one with first names, last name, and username. And we would like to be able to read and map it to a Java representation. Now, the lowest level, very much the same as JDBC. JDBC, if you remember, JDBC provided us with a very low level API that allows us to parse each row and iterate each field and retrieve the data and manipulate that data. We have that equivalent support here in Java as well. They all are part of a specification by the W3C organization that provides a data model representation of how to describe XML documents. Right? We have an object that represents the entire document, and then we also have other objects that represent each individual node as you iterate, and you walk the tree, the DOM tree. DOM stands for Document Object Model. So once you parse this ASCII XML into memory, we generate an object representation of this ASCII in memory, and this representation in memory is referred to as the DOM, the Document Object Model, and the libraries provided are managed by a consortium, the W3C folks that provide the interfaces, and then either C# or PHP or whatever, any language or infrastructure you choose, they will have implementations of these interfaces that allow you to have a standard way of interacting with these low-level tags. So here we're just going to go real quick on how Java would handle this. We can first ask for use a library inside of the here javax.xml.parsers. So this is a family of parsers that know how to, if you give it a file, it'll parse it into memory, and then you can navigate through this document. So real quick, you can start off with a document builder factory. And the factory, you can ask for a new instance. It's using the singleton design pattern, where it instantiates this instance, and then you can use this a single instance to then parse through XML files. So here you can, once you have the database builder, the document builder, you can start a new document builder and then pass it an XML document through a file. And say parse it. Once you parse it, you can optionally call that document and to normalize it. Here we have the document being parsed and represented by in memory by this variable doc of type document, and the document provides all sorts of methods that allow you to find and retrieve different nodes in the document. It represents the same kind of interface that we have in JDBC. In JDBC, that we have the select statement, right? In the select statement, you can provide an SQL select statement that gets executed against the remote database, right? Here, the query is being done against a document that has been read into memory, right? So as opposed to going out to some server that is parsing your SQL query and then coming back with some result sets that you're going to iterate over, right? Here, the document has been already parsed into memory, right? So we have now in memory, in RAM, we have a root document, the root element, and then all the all the pointers to all the other nodes pointing to each other all the way down to the leaves. Yes. Now this document might be a fairly large document, right, containing thousands and thousands of nodes, right? Each node representing a student, a course, a section, an enrollment, right? Created in this huge XML document that has been read into memory. So now that it's read into memory, you need to be able to answer questions, just like you send an SQL query through JDBC back to a server. Here too, we want to be able to query the document. Find me all those students who graduated in 2009, right? Or find me all the enrollments where a teacher failed everybody, right? So we'd like to be able to query, right, and iterate and find me all the instances of the elements that meet a particular criteria. Make sense, right? So all those queries can be done against the doc element, the doc object that gets parsed and retrieved from here. We can ask for the root, right? The document element. This gives you the root of the document. Here we are asking for the notice that the XML document is this one, right? Students, notice it's the root, right? That contains then several instances of student. So here, if we ask for the root, and then we ask for .get node name, the node name is the label of the tag. So students is the label, right? And so we can ask for the name of the node, and this prints out students, right, as a string. We can then start iterating over it. We can say, well, find me different nodes, and yes. Yeah, so usually there's in the XML is going to have a lot of white spaces that are mostly for human consumption. We'll have tabs and new lines and all that, which are not really needed for the XML document. So what Normalize does is it cleans everything up and removes any unnecessary things and make sure it prepares the document for query. Okay. So this doc, right, has all sorts of functions that allow you to query it in different ways. You can retrieve elements of a particular document name that has a particular attribute that is equal to a particular value, and then it returns a list of nodes that match that criteria. The list of nodes is one of the main data types here by the W3C. You see W3C DOM node list. Node list is the equivalent of a result set in SQL in JDBC, right? But in JDBC, the result set, it comes from a specific table or from a specific join. Yes, it doesn't. One of the elements in a row might be a foreign key that you could use to perhaps go fetch more data. Yes, but here, right, there is no more data that you can go fetch. Everything has been read into memory, right? And you would have to, if the equivalent of navigating to another table here would be, the equivalent would be to navigate through a particular branch in your XML document. Okay, right? As you navigate through the node list and more nodes underneath, it would be the equivalent of doing joins, right? Of following links or foreign keys and primary keys. There is no foreign key or primary key, right? The equivalent of primary keys and foreign keys here in XML is XML elements that are nested inside of each other. Okay, that's the equivalent, right? Because I mean that's exactly what foreign keys do. Foreign keys and primary keys allow you to create hierarchies, right? Where you have a parent, child, parent, child, parent, child. Yes. But really, the data is all stored in flat tables, right? There is no hierarchy. We invent the idea of hierarchies through the primary key and foreign keys. Here, the hierarchies are literally implemented through the nesting of elements within elements. Yes. Okay. So there is no need of primary keys and foreign keys. Okay. So once you now that we have once we have the doc, again, the doc allows you to navigate and find other nodes. Here we have, for instance, we're asking the document to find all the elements anywhere in the tree. It doesn't matter, right? Here we are indiscriminately retrieving all the elements who have a tag name of student. In this case, we just have 2 students, right? We have Alice and Bob, right? So this get element by tag name is going to walk the entire tree finding all the elements, right? So we got to be careful. There might be thousands of elements. So this could be a really big query, right? That has to iterate, through the tree, retrieving all the elements, all the elements, yeah. And we have the students here, which is of type node list. This is the node list. We can just iterate over the node list. We can get the length to see how many nodes there are, and then iterate one at a time and get each element one at a time. So each student, we can check to see the type. Here, all the elements that we have here are all of type elements. Well, actually, no, we do have a couple that are not elements. Notice the ID. See the ID there? ID equal 1, 2, 3. That is also an element, right? That is not of type, is of type attribute, right? It's also a node in the tree, right? So the element student and the element students and first name and last name, these are all nodes on the tree. The IDs is also a node in the tree, right? But they're different types. The student and the first name and last name, they are nodes in the tree and they are of type elements. Whereas the ID is also a node, but it's not of type element, it's of type attribute. It's an attribute, right? But it's part of the same tree. So here we're asking, as we're iterating, we're saying, okay, give me a node type. I'm going to only consider the element nodes. I'm going to ignore the attribute nodes. Okay. Also, if there are strings, the values of the strings instead of an element is also a node. Right. So, for instance, all these values, node, Bob, Marley, 2, 3, 4, they are also nodes in the tree. Right. They are value nodes. Right. That again, we're only ignoring. We're only iterating over the students through the elements, right? We're ignoring the IDs or the strings. So we're checking to see here that the node isn't an element node, so we're going to skip over anything that is not an element node. If it is, we can safely cast the node into a more specific type of node, the element node, right? If it is, then the element node has a few APIs that are useful. We can, for instance, ask element nodes certainly have attributes, right? So we know that since it's an element, we can say, all right, well, get me the attribute of that student node who has a particular attribute called ID. And once we have the ID, we can perhaps print it. We can also find another element as a child. Right? We can say, well, from the student, navigate down and find me another node by its name, first name. And this returns a node list of which we're only grabbing the first. See that dot item 0? Right, so this returns a node list of which we're only grabbing the first one. Also, we're grabbing the last name, and finally we're grabbing the username, and then we're going to print it out. We're printing it out. Okay. Right. So that's an example of parsing it using a very, very low level API. You would probably never do this. Right, very much like you would probably never use JDBC. Well, actually, no. JDBC is also very useful. Usually you would use perhaps something like JPA, which gives you a higher level abstraction, and only when necessarily you would perhaps go all the way down to JDBC. Same thing like here, right? You would probably never use something so low level as parsing the document element by element, right? But you might need to, right? But so certainly JDBC. I mean. The JavaX DOM support allows you to do that. Here's just another example using movies, right? Doing the same thing, just iterating over the movies and displaying the IMDb and the values.